solid back to gas.
Meanwhile, roving robots explore near the equator. Spirit and Opportunity use high-resolution imaging and spectroscopy to find evidence of minerals and landforms shaped by water in Mars' ancient past.
Day in the life of a Mars rover starts as the sun rises and illuminates the solar panels, and that wakes up the rover. The radio commands are sent from the Earth to tell it what to do. This time, drive 10 meters forward, and then stop and turn 20 degrees, and then take a panorama with these color filters looking off in that direction. Near the end of the day, one of the NASA orbiters, like the Mars Odyssey orbiter or the Mars Reconnaissance orbiter, is passing overhead, and we know when that's going to happen. The rover will transmit data from that day up to that orbiter, and then that orbiter relays it back to the Earth. And while it's sleeping, we've got those pictures that it just sent back and other data, and now we're trying to figure out what happened. Did it do what we were expecting it to do? Did it do something unexpected? Is it in some dangerous situation?
In early 2008, signals from Spirit indicate trouble. Its right front wheel jams. When the Phoenix team tries driving the rover in reverse, the dragging wheel gouges several inches into the soil and hits silica.
On our own planet, where do we find silica? Well, hydrothermal environments. Maybe that's what we're seeing on this other world as well. So a lot of the excitement about silica is because of that connection to our own planet. That indicates that, hey, maybe those kinds of environments existed on Mars as well. In fact, the Spirit rover may be parked at one right now, right next to it, what may have been an ancient Yellowstone-like hotspot.
It's a classic accidental discovery and raises the question, could Mars have current underground thermal activity?
Is Mars still hot in its interior? It certainly is. There's no way that Mars has completely cooled off all the heat of its accretion, all the heat of its formation. Some of it is still there, plus heat from radioactive elements. There's definitely sufficient heat inside of Mars to make hot fluids percolate, but there is that possibility where you might find liquid water at some depth in the crust, yes.
In Yellowstone and at hot springs all over Earth, many different species of bacteria feed and grow in the gas and mineral-rich waters. Could hidden hot springs be breeding grounds for life on Mars?
We would love to send electromagnetic sounding instruments to the planet because they could actually tell us whether there is liquid in the crust at some depth. That would be fantastic. Then we'd know.
While the Spirit team wonders about Mars' underground mysteries, the Phoenix team finds another surprise on the surface. 2% of the soil around the Phoenix lander is composed of perchlorates, combinations of chlorine and oxygen.
The discovery of perchlorates on Mars has been fairly controversial because on Earth it's a very toxic substance.
On Earth, perchlorates are used as propellants in fireworks and rockets.
This was a surprise. This was a discovery. Why is it even there? How is it forming? The question of perchlorates is a really good question, and there's no definitive answer.
Perchlorates do occur naturally in places like Chile's Atacama Desert, as ultraviolet radiation from the sun transforms chlorine and oxygen.
And on Mars, many of the same kinds of chemical reactions might be happening on the surface. We don't understand the details of even on the Earth, let alone on Mars.
The other challenge with perchlorates is they affect some of the experiments that people use to look for organics, for carbon-based molecules like you might find in life.
Some scientists are now reconsidering the famous 1976 experiments by the Viking lander.
When Viking went to the surface in 1976, they found no evidence whatsoever of organics. One of the recent theories that's being bandied about is that if you did have perchlorates in the soil, that those might have actually broken down the organics in the same process you were using to try to detect them as you heated the soil up.
Perchlorates may have destroyed organic materials in the Viking experiment. And on Earth, they're a key poison in many chemical runoffs. But perchlorates are also power sources for certain bacteria. Bacteria actually used to eat toxic wastes.
And in terms of life, it's a good news, bad news thing.
While microbes might feed on the toxic soil, it could be deadly for humans on Mars.
We don't know how that perchlorate compound might be changing the surface. The surface might be in some kind of a superoxidated state that could ultimately prove to be, for example, corrosive to astronaut suits.
One thing is certain. After 5 months of exploration, Phoenix's mission is threatened by a dust storm sweeping across the Martian plains, burying everything in its path. In a storm so fierce, the Phoenix lander is doomed. When NASA's Phoenix lander digs into frozen water on Mars, it finds new evidence that the red planet could once have harbored life. But in the autumn of 2008, Phoenix's own life is about to end.
On Mars, the wind comes along and whips up the dust, which is very, very fine-grained, like flour, extremely fine-grained material, whips it up into the atmosphere, and it slowly settles out, blanketing everything.
Red dust coats the solar panels of the Phoenix lander. Sunlight, its only source of power, can't get through.
The Phoenix lander has to spend a lot of time recharging its batteries because we know that it's going to get very cold at night and it's going to have to run those heaters at night to stay alive.
On November 2nd, 2008, Phoenix shuts down for the last time. As the Martian winter deepens, frozen carbon dioxide piles up and imprisons the probe in a tomb of dry ice. But Phoenix's data continues to be analyzed.
Going to Mars and taking measurements on the surface, getting detailed data about the history of Mars and Mars chemistry of the surface was an essential piece to determining for sure that water existed on Mars.
Water is essential to life. But according to the latest evidence, it's only one of many forces that shaped Mars.
You can kind of break down our thinking of Mars now into maybe like 4 quarters of a football game.
The first quarter, from about 4.6 to 3.2 billion years ago, is action-packed. Mars forms along with the other planets as swirling gas and debris combine and cool into a rocky world. Then, Mars is bombarded and scarred by meteoroids.
There was a lot of cratering going on, and then towards the end of that period, there was a lot of geologic features that suggest that there was water flowing on the surface.
That new evidence includes this series of ridges, photographed in 2009 by NASA's Mars Reconnaissance orbiter. It's the first definitive lakeshore discovered on Mars. The remains of a lake the size of North America's Lake Champlain.
Every piece of evidence about the presence and the history of water on Mars is so important to determining whether we might be alone in the universe.
Some scientists even say that 3.5 billion years ago, an ocean the size of the Atlantic covered 1/3 of Mars.
Maybe with enough time and enough water, life formed on Mars as well.
As the first quarter of Mars history ends, the second starts with a bang. As volcanoes reshape the planet.
There was significant volcanic activity. Olympus Mons is the biggest volcano in the solar system. So we know there were big volcanoes in the past.
Mars is blanketed with black volcanic basalt, like the basalt found around Hawaiian volcanoes.
And the chemicals released from volcanoes, including sulfur, mix with the water that was left and make things acidic, kind of like acid rain on Earth and that sort of thing. At the same time, the atmosphere seems to be shrinking and water becoming more scarce and less stable on the surface.
The loss of Mars's atmosphere meant that liquid water could no longer exist on its surface. Water exists on the surface of the Earth only because of the atmospheric pressure pushing down on it.
Whatever water is on Mars evaporates or freezes. In the third quarter of its history, Mars probably begins turning red from ferrous oxide, rust in the dust.
Take a fresh volcanic rock in Hawaii or Iceland and let it sit out in the Earth's atmosphere, and it's going to turn red and brown over time. It's going to oxidize. Same kind of thing could have happened on Mars.
In its final quarter, Mars goes into a deep freeze. From around 100 million until 2 million years ago, large glaciers form and carve out new patterns in basins and craters. From a warmer, wetter planet to a cold, dry world. Mars in a nutshell, according to recent evidence.
It had a thicker atmosphere, it had water, it may have had rain, it had snow, it has all kinds of things that are familiar to us. And it's just fascinating to think that we can go back in time with these missions and study an early sort of Earth-like Mars that's now gone.
But while there's strong evidence for past water on Mars, these 2009 satellite pictures seem to show something impossible. Flowing liquid water on the surface.
There could be events when water that has been kept subsurface or frozen comes gushing out and runs down the walls of these craters.
This is one of the most exciting things in the past decade, is seeing those pictures of the gullies. Because when I grew up, I was taught that there's no way liquid water could be stable on Mars today. And this kind of flies in the face of the physics, right? And that's kind of exciting, because it means that we might have something wrong.
The initial announcement of finding them proposed that ice that was melting or an aquifer coming up. There's a whole different set of theories and recent study that it could be from carbon dioxide, the dry ice going to a gas, and then that gas basically doing a gas lubrication of the sand that's flowing down. And frankly, it's still in the midst of exploratory science right now.
And some of these marks have been shown to be dust flows. I hope not all of them. I'd like them to be water.
From ancient oceans to yesterday's flowing gully, the search for water and life on Mars is an ongoing quest. A quest that, like a climber's path along an unfamiliar course, is filled with false starts and unexpected detours. That's what happens when this photograph, taken near the Martian equator, reminds a lot of people of this. Could Mars once have supported life? Mineral evidence from probes like the Spirit rover is encouraging, but it can be radically overinterpreted.
You know, we have to be careful not to jump over a line that goes beyond what the current data, the current experiments, the current hypotheses can support. But it's hard as human beings not to just jump over that line.
In 2008, thousands jumped to an incredible conclusion when a picture taken by NASA's Spirit rover goes viral across the internet. Doesn't this figure look amazingly like pictures supposedly taken of Bigfoot? Is this proof of life on Mars?